Hello everyone, in this session we will discuss virtual memory, which is part of Unit 4 IO and memory. So from the name virtual memory, you will know that it is not physically available. So we have the processor, then we have the cache memory, then we have the main memory, and then you have the disk storage. And within the cache memory and the processor, you have an effect as if the entire memory is available to the processor. That effect given by the memory management unit, you call it as the virtual memory. So we'll see how it happens. So we know that to execute an every instruction by the processor, the instruction should be available in the cache memory, and the same instruction data and instruction will be available in the cache memory, and copy of it will be available in the main memory, and this has to be brought from the disk storage. So here the addresses of the main memory from the disk storage, when you load it into the main memory, the addresses of the main memory are physical addresses. So processor will give a virtual address. So instead of having the frame number, you will have your program will be divided into page numbers and word number. So the virtual processor will always give virtual addresses. That is page number, word number within that page. Now, depending on where exactly it is loaded in the main memory, the conversion of the virtual address to the physical address will happen. That translation, you call it as the virtual memory. So the advantage of virtual memory is it is very simplified, it is cost effective, and you have lot of access control. So this is the address translation that happens. So processor gives the virtual address. The virtual address contains the virtual page number and offset. And whenever a page is brought from the disk and stored into the main memory, it will be entered into a page table. A page table is a table which will be maintained by the operating system for every program in execution. So that keeps track of where exactly each page of that program is loaded into the physical main memory. So this page table will contain for page number and the corresponding frame number where exactly it is loaded. So from the virtual address, it goes into the index of the page table. So from the index of the page table, you will get the page frame number. So virtual page number is replaced with the physical frame number, and the offset is not changed. So this becomes the physical address. So this is the address translation that happens in virtual memory address. Now, since in a multi-programming environment, there are more than one program that will be executed. So more than one program that will be in execution. So every program in execution should have a page table. So you will have a number of page tables that will be maintained by the operating system, and that page table's base address will be given in a page table base register. So page table base register plus the virtual page number will give you the exact index into the page table. And if the page table is stored in the main memory, then again for our aim of introducing the cache memory is to reduce the main memory access. So to reduce the main memory access. So if the main page table is stored in the main memory, then for every page you need to access the main memory. So you have to store the page table in a cache memory called memory management unit. So which will reduce the number of main memory access. And still further, if we want to improve the translation time page from the virtual address to the physical address, we can store the current translation in a special register, so that because all we know that successive memory locations are going to be accessed, and we need not do the entire translation process. For a particular page, the translation is already available. So if the access of successive memory locations are from the same page, we can use the same physical address, page frame address. So that is how we can reduce the translation time. And this method, you call it as the translation look-aside buffer, the cache memory that is introduced so that you can store the page table. You call it as the translation look-aside buffer, which will be incorporated in the memory management unit. Thank you.